When we think of unexplored places, we usually imagine distant planets or the deepest jungles, but right here on Earth, beneath your feet, under miles of ocean and layers of solid rock, there's a world so bizarre and mysterious that scientists are only now beginning to understand it. We've been taught that the ocean floor is just, well, the bottom, sediment, rocks, maybe some hydrothermal vents. But what if I told you that beneath that seafloor, there's an ocean 3 times the size of all the water on the surface? Or that there are buried mountains, ancient seafloors from the time of dinosaurs, and geological processes that completely flip our understanding of how Earth works? Today, we're diving deep, really deep, to explore the most surprising, mysterious, and mind-bending discoveries ever made beneath the ocean floor. Let's start with the biggest discovery, literally. About 700 kilometers beneath your feet, deep within Earth's mantle, there's something that shouldn't exist, an enormous reservoir of water. Now, this isn't an underground lake or cavern. The pressure down there is so immense that rock behaves like plastic. So how do you hide an ocean in solid rock? The answer lies in a blue mineral called Ringwoodite. Think of it like a sponge made of crystal. When scientists analyzed seismic waves from over 500 earthquakes using 2,000 seismometers, they noticed something strange. The waves were slowing down as they passed through this region, and the only explanation was that the ringwoodite there was saturated with water. How much water? We're talking about enough to fill Earth's surface oceans 3 times over. This discovery completely rewrites our understanding of where Earth's water came from. For decades, we believed that water arrived here via icy comets and asteroids bombarding the young planet. But this suggests that Earth's water might have been here all along, slowly seeping up from its interior over billions of years. Think about that. Every glass of water you drink, every ocean wave, every raindrop, it may have originated in the dark, crushing depths of the mantle, 700 kilometers down. Now let's travel to Bermuda, a paradise known for pink beaches and turquoise water. But beneath this vacation destination, there's a geological mystery that has puzzled scientists for decades. Bermuda sits on a volcanic platform that hasn't erupted in 31 million years. Normally, when volcanoes go extinct, the land cools, contracts, and sinks. But Bermuda hasn't. It's remained elevated, defying the basic rules of geology. Scientists finally figured out why, and the answer is absolutely wild. Using seismic imaging, basically a CT scan for the Earth, researchers discovered a massive structure buried beneath the ocean floor near Bermuda. It's a layer of rock, roughly 20 kilometers thick, that's 12.4 miles, sitting between the oceanic crust and Earth's mantle. This layer shouldn't exist. In normal ocean crust, the crust sits directly on top of the mantle, but here, there's this enormous blob of less dense rock, acting like a geological flotation device, keeping Bermuda lifted above the waves. Where did it come from? Scientists believe it's related to ancient processes in Earth's mantle, maybe even leftovers from when the supercontinent Pangaea broke apart. Whatever it is, it's a reminder that we still don't fully understand what's happening beneath our feet. Speaking of things that shouldn't exist, let's travel to the East Pacific Rise, an underwater mountain range where tectonic plates are pulling apart. And hidden deep beneath it, scientists found a ghost, a fossil, but not a dinosaur bone, a fossilized fingerprint of an ancient seafloor that sank into Earth's interior during, get this, the age of dinosaurs. This slab of oceanic crust began its journey downward roughly 250 million years ago, when the earliest dinosaurs were just appearing. It should have sunk all the way to the core mantle boundary by now. Instead, it got stuck in the transition zone, about 660 kilometers down. This discovery, made using advanced seismic imaging, tells us something revolutionary. Material moves through Earth's interior much slower than we thought. The mantle isn't just a conveyor belt smoothly transporting material, it has barriers, traffic jams, places where stuff gets stuck for hundreds of millions of years. It's like finding a letter that was mailed 250 million years ago and only just now arriving at its destination. If you thought regular volcanoes were impressive, wait till you meet Abzu and Tiamat. No, those aren't characters from the next fantasy movie. They're mud volcanoes, and they're unlike anything we've ever seen. Located about 200 kilometers southwest of Portugal in the Atlantic Ocean, these structures were discovered by an autonomous underwater vehicle named Abyss, and what they found changed our understanding of how fluids move through the planet. Normal mud volcanoes form when sediments on the seafloor get compressed and push water and mud upward. It's a shallow process, but Abzu and Tiamat are different. The fluids they're expelling are coming from deep within Earth's crust, possibly even from the mantle. This means there's a direct connection between the surface ocean and the deep Earth. Water is cycling down through fractures in the crust, traveling kilometers deep, and then returning to the surface through these volcanic chimneys. We name them after ancient Mesopotamian gods of the ocean and primordial waters, and honestly, that feels appropriate, because these volcanoes are literally bringing messages from the deep Earth to the surface. Finally, let's head to the North Sea, off the coast of Norway. Here, buried beneath the ocean floor, scientists found something that defies geological logic: giant mounds of sand, some covering areas up to a square kilometer. But here's the weird part. These sand mounds are sitting underneath layers of mud. In geology, younger layers are supposed to be on top of older layers. It's basic stratigraphy. But these structures, now called Sinkites, completely flip that rule. Here's how they formed. Imagine a layer of soft, ancient mud. Above it, denser sand begins to accumulate. The sand is heavier, so it starts sinking into the mud below, like a heavy stone sinking into wet cement. But because the mud is less dense, it gets displaced and rises up around the sinking sand. The result? A giant blob of sand surrounded by mud that used to be on top of it. It's a complete reversal of the normal order. Why does this matter? Because understanding these structures is crucial for things like carbon storage. If we're going to pump CO2 into underground reservoirs, we need to know exactly what's down there. Surprises like Sinkites could make the difference between safe storage and catastrophic failure. So what have we learned? That beneath the ocean floor, there's a world we're only beginning to explore, a hidden ocean in the mantle, a 20-kilometer thick blob holding up Bermuda, a 250-million-year-old fossilized slab, mud volcanoes connecting surface to deep Earth, and geological formations that completely defy our expectations. Every time we develop new technology to look deeper, we find something that challenges what we thought we knew. And that's the amazing thing about science. It's not about having all the answers, it's about asking better questions. What do you think is still hidden down there? Another ocean? Ancient life? Something we can't even imagine yet? Let me know in the comments. And if you want to join us on more journeys into the unknown, hit that subscribe button. Thanks for watching, and I'll see you in the next one.